Hello students, welcome to Tuteetute. In our last sessions, we have seen different questions from all the subjects. In this session, we will see the questions from the two-port networks and similarly three-phase circuits. Okay, so let's see the first question. In a two-port network, open circuit impedance parameters expresses. Okay, so that means they are asking about open circuit impedance parameters. Okay, so open circuit parameters. So we know this one. Okay, so open circuit parameters means, so they are asking about Z parameters. Yes or no? Just Z parameters. See, this question might be simple for many of the students because so this is the basic question they are asking from the two-port network. So but we need to understand in depth about this kind of questions. So I will give you all the two-port network parameters, like 4 parameters I will be giving. From that we will be understanding. Okay, so they are asking about the equations. Okay, so V1 V2 in terms of I1 and I2, I1 and I2 in terms of V1 and V2. If anybody wants to know the answer, they are asking about impedance parameters. To get the impedance parameters, so what we need to give? So V1 equals to V2 equals to, in terms of I1 I2 we will be giving like this. So these are the two equations. Okay, so here it will be Z11, here Z12, here Z21 and here Z22. So it will be plus here. Okay, simple. Okay, so I1 and I2 in terms of V1 V1 and V2 we are giving in terms of I1 and I2. Okay, so that's what. So V1 and V2 we are giving in terms of I1 and I2. Okay, so this is the answer for us. Okay, so directly we can do like this. Okay, so there is no problem at all. Okay, we can directly do like this. But see, from this question we need to understand even more. Okay, so like any parameter, so they have asked about open circuit impedance parameters. They may ask about H parameters. Okay, so where we will get generally difficult H parameters or ABCD parameters, we will be getting the difficult. Okay, so I will give you, so all these independents and dependents are unknowns and knowns at each and everything. Okay, so first to understand all these Z parameters, how we need to represent. So Z parameters, equations only we need to remember. Okay, so V1 equals to V2 equals to, okay, in terms of I1 I2. Okay, so it's easy to represent in terms of matrix, right? Otherwise equation anything. Okay, so I1 and I2. Okay, so I1 and I2. So here you will be getting Z11, Z12, Z21, Z22. Okay, plus and plus. Okay, so this is the one. So we are giving V1 and V2 in terms of I1 and I2. Okay, so that is the one we have understood already. So here V1 and V2 are dependents. Okay, V1 and V2 are depends on I1 and I2 values. Okay, V1 and V2 are the unknown values and I1 and I2 are the known values. Okay, so like this we need to understand. Okay, so this is Z parameter. So next Y parameters. So Y parameters means how we need to understand. So same. Okay, so I1 and I2 we need to represent in terms of V1 and V2. V1 V2. Okay, see, for quick revision it will be more useful. Okay, so that's why I'm giving like this. So here Y11, Y12, Y21, Y22 will be there, plus and plus. Okay, so these two generally everybody will be knowing. Okay, so remaining, so the H parameters, how to remember? Okay, let's give the ABCD parameters first. Okay, so T parameters. Okay, so T parameters are ABCD parameters. Okay, so T parameters are ABCD parameters, transmission line parameters. Okay, so how to remember these? See, remember one thing, if you are electrical or electronics. Okay, so ABCD parameters generally we used to represent for the transmission line. Okay, so if you know this one, like in EMF subject, otherwise in power systems you will be understanding this one. So we used to represent the ABCD parameters for the transmission lines. Okay, so for the transmission line, so we have two ends. One is the sending end, another one is the receiving end. Okay, so for the transmission line, at one side, sending end side, generator is present. At the receiving end side, the load is connected. Yes or no? For any transmission line it is. Okay, it may be how much long, no need for us. Sending end side generator, receiving end side we have the load. So you tell me the transmission line has to transfer the power through this transmission line, which power it has to transfer? According to load requirement. See, how much load is required, how much power is required at the receiving end side, that much we need to send from the sending end side, okay, plus some losses. For example, this transmission line is not having any losses, then how much load is required here, that much we need to send from the sending end. That means how much voltage and how much current your load is required. Understanding? How much current and how much voltage your load is required, okay, so that much we need to send from here. Understanding? So the sending end voltage depends upon the receiving end side voltage and current, because that much we need, that's why we need to send that much of current and voltage from here, okay. So that means for any transmission line, load is fixed. You observe any load, you take any load, okay, voltage for that and current means wattage for that, it will be fixed, okay, like any of the load parameter, okay, so the voltage and currents are fixed load parameters. That means for any two-port network, so what are the load parameters? V2 and I2, okay. That means for any transmission line also, or T parameter representation also, V2 and I2 are fixed one already, okay. V2 and I2 are fixed. What are unknowns for us? We need to generate certain voltage. How much is required at the receiving end side? V1 equals to, next I1 equals to, okay. So as usual, V2 and I2, okay. So for understanding it may take 5 minutes, okay. So but if you remember once, you will be getting this is A and this is B, this is C and this is D, okay. So here some people may get, here we have to give the minus sign or plus sign, okay. So this is general doubt only, for everyone we will get this doubt. So understand, so generally for the transmission line, the current will be sent from this side and the same current will be taken for the receiving end side like this, okay. That means I1 and I2 current directions are same. This is I1, this is I2, if you consider this as the two-port network. But generally for any two-port network, how is the I1 current direction? Like this, and I2 current direction is like this. If you have understood from our classes, I will be giving certain points here. So what are the considerations? Every time the currents are going into the two-port network, that is the consideration, okay. So that's how we are giving these equations, okay. Always the currents has to go inside the two-port network. But see, for the transmission line, this is the perfect example, okay. So the current is going in this direction, other side also current is in this direction only. If you consider, so this as the two-port network, okay, so this as the two-port network, so then this current direction is reverse. So that means you need to represent it as the minus here, okay. So that's what we are doing in all our problems, okay. So but remember, if you put minus here or plus here, follow the only one notation, okay. If you are following with minus, follow like that. If you are following with plus, follow like that, okay. So generally we used to give as the minus, because this representation we are giving, okay. So that's why these are the minus will be there, okay. So the next one is H parameter, okay. So this is also important for us, H parameter, okay. So for H parameters, what are the important things, what are the, so like what are the dependents, what are the independents we need to understand, okay. So I will give you directly one shortcut, remember that. So V1, I1, V2, I2, okay. So like this we need to give, okay. So V1, I1, V2, I2, if you write like this in order, okay, V1, I1, V2, I2, okay. So you will get, otherwise I will tell you one more shortcut also, okay. So V1 equals to H11 I1 plus H12 V2. So next I2 equals to H21 I1 plus H22 V2, okay. So this is the complete equations, okay. So two equations these are. So from this one, okay, so we need to get I1 and V2, okay. I1 and V2 are the independents, okay. So they are not depending, and V1 and I2 are the depends. Okay, so these are the dependents on this current and voltages. Okay, so like this we need to understand. Okay, so here also what we are representing, if they ask about H parameter in this question, what we need to get? So okay, so H parameters, V1 and I2 we need to represent, V1 and I2 we need to represent in terms of V2 and I1. This is for the H parameter. Okay, so next V1 and I1 in terms of V2 and I2, V1 and I1 in terms of V2 and I2. Okay, so this is ABCD parameters or T parameters. Next I1 and I2 in terms of V1 and V2, I1 and I2 in terms of V1 and V2. So this is Y parameters. Next V1 and V2 in terms of I1 and I2, these are Z parameters. Okay, so what is the advantage of learning these equations? Remember one thing, if you know these four equations, four sets of equations, okay, so any problem in two-port network you can solve. Okay, so remember one thing, only these equations you need to write down. Whatever they are asking in the question, everything we can get from these equations. Okay, even the problems also, if they are asking about y21 value, okay, what you need to do, you just need to make this one 0. Okay, so make this one 0 means V2 equals to 0, then you will be calculating energize certain source and you will get easily. Okay, so that we have discussed already in our classes actually. So whenever you are writing these four sets of equations, you can even get each and every value. Okay, see here one more thing also important for us. So one thing, the units of each and every parameter here, like Z11, Z12, everything is in terms of ohms only. So but here for the admittance parameters, okay, so everything will be in terms of mho. Okay, units of Y11, Y12, all these. Okay, so units of these T parameters, so A units, no units A. Okay, so how no units? V1 divided by V2, okay, no units. Okay, so next B units. So what are the B units? V1 divided by I2, V divided by I. Okay, that means voltage divided by current is nothing but in terms of ohms. Okay, so if anybody don't know, just try this. Okay, so just put your hand here, voltage divided by current is B. Okay, so the like that. Okay, then C in terms of ohms. Okay, so then D, what are the units of D? Current divided by current, so no units. Okay, so no units. These are important for us. Okay, so they may ask this kind of questions. So some people will definitely do mistakes in here also, because some people don't even concentrate more on the two-port networks. Okay, so similar to this for the H parameters also, tell me the units. Okay, H11, units of H11 in terms of ohms. Okay, so H12 units, no units. H12 units are voltage divided by this voltage, no units. Okay, so H21, what are the units? No units. Current divided by current. Okay, so H22, what are the units? So just observe, H22 units are current divided by voltage. Okay, so current divided by voltage means it will be mho. Okay, so like this all the parameters, and remember whenever you get all these equations, okay, you can solve any kind of problem from the two-port network. You will start the analysis whenever you know these equations. Okay, if you don't know, you won't be solving any questions from this. Okay, so anyhow, if you need more concepts about this one, just understand from the classes. Okay, so these are more interesting also. So the next one, when two-port networks, okay, when two-port networks are connected in parallel, it is convenient to use. Okay, so two-port networks connected in parallel. Parallel means, so this is first two-port network and this is second one. How they have connected? Okay, for the first two-port network, these are the 4 terminals. Second one, so these are the 4 terminals. What is parallel connection? See, don't think like I don't know. Okay, so I know the answer directly. Two-port networks connected in parallel. Okay, so parallel they have connected directly. Admittance parameters we need, our short circuit parameters. I know the answer. Okay, I want to give you certain analysis and revision. That's why I'm explaining. So parallel connection means here certain voltage is there, here certain voltage is there, here certain voltage and here certain voltage. Input side has to be connected in parallel, output side also has to be connected in parallel. So whenever two resistors connected in parallel means, so voltages must be same, right? That means if this voltage is equals to this voltage, how it is possible? If you connect these two like this, okay, So if you connect these two also like this. Now if you consider this as the one voltage, voltage across these two terminals is V, voltage across these two terminals is V. Okay, so if they have connected like this and connected like this is not complete parallel connection. Okay, so this is only input side parallel they have connected, output side is not connected in parallel, so we cannot consider this as the parallel connection of two port networks. This is not a parallel connection yet. Okay, so how we need to do? So again the output side, otherwise second port sides also we need to connect like this. Now this is the complete parallel connection. Okay, so why I'm giving this one? Because some problems will be there. Okay, so where input side they have connected in one connection, output side they have connected in another connection, they will be asking what kind of connection it is. Without seeing we will be answering, so that's why I have given this. Okay, so this is a parallel connection of two port network. What is a series connection? Series connection means, so this has to connect. So generally for any resistors, if they are connected in series, what will be happening? Current in the first network or first resistor is equals to current in the second resistor also. Okay, like how much current will be going, same current must come like this and same current must come like this also. Okay, so similar to this other side also, this is a series connection of two port networks. Okay, so in series connection, so voltages will be added. Okay, so this is V1 voltage, this is V2 voltage, this is a complete voltage from here to here. Now this is our complete two port network. Okay, so that means this is the two port network connection in series. What is cascade connection? Cascade connection means one end of the two port network is connected to another end. Okay, that means one end of the two port network, this two port network is connected as the input to the other side of the two port network here. Okay, so this is cascade connection. Okay, so whenever two port networks are connected in series, whenever two port networks are connected in series, Z parameters calculation is easy. Okay, so whenever two port networks are connected in parallel, okay, so parallel they have connected, then Y parameter calculation is simple. Okay, so whenever two port networks are connected in cascade connection, okay, so cascade connection, so then which parameters calculation is easy? ABCD parameter calculations is easier for us. Okay, so that means complete ABCD parameters. Okay, so that's how, when according to the connection of these networks, we need to do the calculations. If cascade connection is there, if I try to calculate the Y parameters first, I will not get even very small steps. Okay, it will take longer procedures. Okay, that's why, so we need to solve using certain methods only. Okay, so when two port networks are connected in parallel, it is convenient to use, which method is convenient to use? Short circuit admittance parameters. Okay, so that is the more comfortable thing. Okay, so open circuit impedance parameters when it is series connection. Transmission parameters, it is our cascade connection. Okay, so inverse hybrid parameters, which connection? So you have to find out this one. Okay, so if you have any patience, just try this one. Okay, and tell me also. And next question, the value of the parameter A for the two port network shown is, okay, so for the two port network shown, they are asking the value of A. A means it's a transmission line parameter, first one. Okay, so V1 divided by V2. Okay, so that's what they are asking, V1 divided by V2. Okay, so V1 is this one, V2 is this one. So there is no voltage present here. Okay, no source is present. How much voltage is between these two? So no current will flow like this. Same voltage will be across this one also. So V1 by V2 equals to 1. Okay, so directly we can solve, but you will not be satisfied like this, right? Okay, so we need to solve using other methods also. Okay, so ABCD parameters they are asking, we can solve this using, so I will consider this as the one network, one two port network, and I will consider this as the another two port network. So this is two port network 1 and this is two port network 2. Both are connected in cascade. Whenever two cascade connections are there, individual transmission line parameters we have to matrix multiply. Okay, so remember, matrix multiplication we need to do. Okay, see, whenever only one admittance is there, okay, so only one admittance in parallel, admittance value is Y. Okay, so the ABCD parameters of this one or T parameters of this network is nothing but, so 1 0 Y 1. Okay, whenever only admittance is there, whenever only series impedance is there, okay, only series impedance is there, then our ABCD parameters of this kind of network is nothing but so 1Z01. Okay, so these are the two shortcuts directly we need to remember. So this is a parallel one 0 y means admittance and 1. Okay, so this is 1Z01, Z means impedance of this one. Okay, generally impedance will be in terms of ohms, admittance will be in terms of mho. Okay, so here also one network is like this and one network is like this. So directly these two network ABCD parameters we have to give. For the first network 1 0 y is not 5 here, see, y is 5 ohms. So what we have to give? Admittance in terms of mho we have to give this one. Okay, that means 1 by 5 and 1. Okay, so this is for the first network and this is for the second one 5 ohms is connected in series like this. So 1 5 0 1. Okay, we need to do matrix multiplication. Okay, matrix multiplication means so one row and one column. Okay, 1 into 1 1 and 0 into 0 1 only. Okay, total is 1 only. So 1 into 5 5, that's it. Then 1 by 5 and next one is 0. Next 1 plus 1 is 2. Okay, so this is the complete ABCD parameters of the entire two-port network. Okay, so here A parameter is 1, B parameter is 5, C parameter is 1 by 5, D parameter is 2. Okay, so here I didn't use even minus signs also, I got this answer. So even if you use the minus signs also, you will get the similar answer only. Okay, why to do like this? I will try to do using the equations. I told you right already, if you know the equations, you can solve any kind of two-port network problem. Okay, understand this method. So this is the network they have given. So ABCD parameters, in ABCD parameters they are asking about A. Okay, ABCD parameters, right? So V1 and I1. So I know these equations. Okay, whenever you see certain problem, they are asking something about ABCD parameter. That equations we need to write down. Okay, V1 equals to I1 equals to V2 I2, V2 I2. Here it is A, B, C, D. Okay, so for easy calculations I am just using the plus sign only. Okay, so there is no problem. So A, B, C, D parameter equations we have written. Now I need A value. I need A value means I need to use this equation. Okay, so in this equation I want A value means I need to do this one as 0 for easy calculation, right? I2 I have to make 0. I2 I have to make 0. Generally I2 in this direction. Why I have written in this direction? Plus I have used it, that's why in this direction I have considered I2. Okay, so this is the I1 value, I1 current. Okay, this is I2. Okay, now I2 we have to make. Okay, from this one, if you make I2 equals to 0, then A value will be equals to V1 divided by V2. V1 divided by V2. Okay, so now how we will get this V1 divided by V2? So we need to energize this source. Okay, so it is I1 value is there, here V1 value, if I consider here as 1 volt source, then directly V1 value we got, right? V1 value is 1 volt only directly. So 1 volt will be giving some current like this, so that current will be flown here only. Because this is open circuit, so no current will flow. So voltage V2 is nothing but voltage in this 5 ohms only. Okay, voltage across this is nothing but again this V1 only. So V2 is 1 volt, V1 is 1 volt we have taken, and V2 is 1 volt we have understood. So that will be equals to 1. Okay, so what is the unit? No unit. Okay, so for the A parameter, no unit will be there. Okay, like this also we can solve. Okay, so here they have asked about A value, that's why we have it like this. For example, if they ask about C, how we have to do? Okay, so make this term equals to 0. Again I2 equals to 0. So then C value equals to I1 divided by V2. I1, what is the value of I1? 1 divided by 5. C value equals to 1 by 5 is the current divided by V2. V2 value is 1, so it will be 1 by 5 value. That's it. So we already know this answer, C value. Okay, similar to this A, B, anything we can get. Okay, so not only this parameter. So just for example, for the given network only, if they are asking about, so just a random question only. Okay, so H11, H12 value they are asking. h12. See, h parameter they are asking. Immediately what you have to write down? H parameter equations. Okay, so v1, i1, v2, i2. Okay, so like this, h11, h12, h21 and h22. Okay, so plus this is i1, this is v2. Okay, so we know the equation now. Okay, so now what they are asking, h12 value they are asking. H12, where it is h12? Here h12 is there. So what you have to do? I1 value we have to make 0. To get the h12 value, if you make I1 equals to 0, that means this I1 means input side, or this side we need to open circuit. I1 we have to make 0. If you make I1 equals to 0, then h12 equals to v1 by v2 you will get. Okay, so v1 by v2 you will get. That's it. So v1 by v2, if you make this one as the open circuit, so if you are open circuiting this side, right? So I will energize this side. So it will be 1 volt here. So 1 volt if I energize here, how much current will be going inside? So see how much current? 1 divided by 10 current will flow. Okay, so 1 by 10 current will flow like this. So here also 1 by 10 current will flow like this. Okay, so now what is the v1 value? v1 equals to, see, v1 equals to 1 by 10 into 5. Okay, 1 by 10 into 5 means 1 by 2. Okay, so v1 is 1 by 2 and v2 value already 1 volt we have taken. Okay, so v1 by v2 is equals to 1 by 2 divided by 1. So h12 value is equals to 1 by 2 you will get. Okay, so like this, simple. Okay, so within 1 minute you can solve using this method. Okay, so think once. Okay, so this circuit may be only 2 elements are there, so may not be 2 elements every time. It may be dependent sources also. So anything we need to follow the equations method, then we will get answers very fast. Okay, so whatever parameter they are asking, according to that we need to answer. Okay, so next question. A two-port network is said to be symmetrical when the following equalities hold good. Okay, so they are asking about symmetrical condition. Okay, so symmetrical, see, symmetrical condition directly I know. Okay, so if anybody thinks, okay, I am explaining too much for this small question only, so my intention is how to give the explanation for you. Okay, for your revision, and you, whenever you see this kind of question once, the entire concept of that you need to get. Okay, so that's what my intention. Okay, so symmetry, condition for symmetry and condition for reciprocity. Okay, so these two we need to remember. Okay, so condition for reciprocity. Okay, so these two we need to remember. So if it is in terms of z parameters, so condition for symmetry is, so z11 equals to z22, symmetrical. Okay, so symmetrical means if you see from this side how much impedance is there, if you see from other side also same impedance must be there. Okay, similar to this in y parameters, y11 equals to y22. So for the t parameters or abcd parameters, okay, so this is important for us. So for t parameters, the condition for symmetry is a equals to d. Okay, so that means, so if you calculate the a parameter and d parameter, you need to get the same value, then that is the condition for the symmetry. Okay, similar to this, for the h parameters, the condition for the symmetry is AD minus BC. Okay, so AD is different. So for the condition for the symmetry in the h parameters is h11 h22 minus h12 h21 is equals to 1. Okay, so if you get this condition, then it is a symmetrical network. Okay, so similar to this reciprocal. Okay, so whenever z12 is equals to z21, it is reciprocal for the same network. So you will definitely get. Okay, so if you calculate y parameters for the same reciprocal network, you will get y12 equals to y21, and similar to that for the t parameters or abcd parameters, so AD minus BC is equals to 1 will be the condition for the reciprocity, and similar to this for the h parameters, condition for the reciprocity is h12 is equals to minus h21. Okay, so here what are important for us? So here, so these 4 are important for us. Okay, so these 4 generally they may give in our examination. Okay, so we need to remember these things. Okay, so these are the conditions for our So symmetry and reciprocity. Okay, so the two-port network is said to be symmetrical when the following equalities holds good. Okay, so Z11 and Z okay, so these two conditions they have given. No need of these two conditions, only one condition is enough. Okay, similar to that, so not only this, if Y11 is equals to Y22, otherwise A equals to D, otherwise so H11 into H22 minus H12 into H21 is equals to 1. This any one condition, okay, so that is correct only. Okay, so this option is correct. And the next question, a balanced delta connected load draws 20 kilowatt at a power factor 0.8 leading. If the line voltage is 800 volt RMS, the magnitude of RMS value of line current will be, okay, so what they are asking, the RMS value of line current. Okay, so line current value they are asking. So and what they have given, the balanced delta connected load they have mentioned. Okay, so it is a delta connected load. Okay, so delta connected load it is. Then what value they have mentioned, so it is drawing a active power of 20 kilowatt at a power factor of 0.8 leading. So that means simple, right? So we need to just give, so the equation for the power, okay, so power equation, so generally power equation is root 3 VL IL cos phi. Okay, so this is the equation for the active power. Okay, so similar to this, if you want reactive power, Q equals to root 3 VL IL sin phi. Okay, so if you need complete complex power, so what you have to give, S equals to root 3 VL IL. In terms of line voltages, all these things. Okay, so see one thing, if the line voltage is 800 volt, okay, so we know the line voltage. So now power factor is 0.8 cos phi we know. So then load draws 20 kilowatt we know. So what we need, only this IL value root 3. Okay, so we know the value of root 3. Okay, so IL value equals to directly, so this is 20 kilo. Okay, so kilo means 10 cube divided by, so root 3 into, so what is the voltage, line voltage only they have given, that is 800 volt. Okay, so 800 volt into, so power factor is 0.8. Okay, so 0.8. So what you will be getting, so you need to simplify this one. So anyhow, so this zeros, okay, so 4 zeros are there in the denominator, only 2 zeros are there. So if you simplify this one, you will be getting as 200 divided by root 3 into 8 into 0.8 is nothing but 6.4. Okay, so 6.4 you will be getting here. Okay, so this is the complete one. So if you simplify this one, so the current you will be getting IL. Okay, so line current you will be getting 6.4 into 1.732, otherwise 64 once and 64 3 times you will be getting 180 plus around 192 you will be getting 64 3 times. Okay, 64 3 times means around 30 point something you will be getting here, divided by root 3. Okay, so 30 point something means, so this 30 we can write down as 10 into root 3 into root 3. Okay, so divided by root 3 we have 10 into root 3. Okay, so what is 10 into root 3? 1.732 into 10. Okay, so that means 17 point something you will be getting generally, but here we have approximated little bit value, that's why, so this will be our correct answer, 18.04 amperes. Okay, so if you have calculator actually, then we can do, otherwise so this we need to do using the normal simplifications only. Okay, so here we need to understand the power calculations. Okay, so these are the powers for in terms of line voltages. Similar to this, in phase voltage, phase values only we have to give. Okay, so like 3 into V phase into I phase into sin phi. Okay, so this will be reactive power. Similarly, active power, 3 phase active power equals to 3 V phase I phase cos phi. Okay, so if apparent power or complex power, 3 into V phase into I phase, if it is a balanced one. Okay, if it is balanced one, so then only these formulas. If it is unbalanced, each and every phase we need to calculate separately, then we have to add all three. Okay, so anyhow we'll see the next question. So the complex power in phase BC of a three phase supply, which with an effective line voltage 240 volt as shown in the figure below. Okay, so this is also one of the previous year question. So effective line voltage is 240 volts they have mentioned. Okay, so this is 240 volt, 240 volt, 240 volt, but this is three phase, right? So it is balanced one or unbalanced one, we need to understand. So the phase, three phase supply it is. Okay, so they have mentioned three phase supply with an effective line voltage. That means so they have mentioned already, so it is effective line voltage means not in one phase. Okay, in all the phases it is 240 only. So like for example, VAB is 240 at an angle of 0, VBC is 240 at an angle of 120, then VCA is nothing but 240 at an angle of this is minus 120, this is plus 120. Okay, so like this we need to understand. Okay, so now what they are giving, so they are asking about the complex power in phase BC. Okay, so where is B and C? This is B. Okay, so this is C. Okay, that means in this load we need to calculate. Okay, that is the complex power. So complex power generally, so S equals to V into I conjugate. We can do like this. Okay, so V into I conjugate. For that we need to calculate the current in this one. Okay, so anyhow this is the delta connection. For any delta connection, so the line voltage means between these two lines voltage. So similar to that phase voltage also. Okay, so line voltage and phase voltage will be same for the three phase delta connection. So that's why, so anyhow here they have given already line voltage. Okay, so line voltages, so we can consider directly 240 at an angle of, so between B and C. Okay, what is the voltage? 240 at an angle of minus 120 degree into I conjugate. I we don't know, so that's why how we have to calculate. So we need to calculate using 240 at an angle of minus 120 divided by, so this impedance 15 at an angle of 30 degree whole conjugate. Okay, so like this we need to do. Okay, so that means 240 at an angle of minus 120 into, so this is 240 divided by 15. Okay, so 240 divided by 15 means what you will be getting, 15 ones. Okay, so then 15. Okay, so this is also 15 ones only. So this is 16, right? Okay, so 16, 15 ones. Okay, so 15 ones, 15 here, and you will be having 90 means this is 6. Okay, so 16 you will be getting 16 at an angle of minus 120 minus 30. Okay, so this is the complete one. So then you will be getting as 240 at an angle of 120 into 16 at an angle of minus 150. Okay, so if you add these two, then you will be getting, and we need to use here conjugate. Okay, so I forgot, conjugate means here you will be getting plus. If you remove the conjugate, you will get the plus here. Okay, so this is plus 150 and this is minus 120, then you will be getting 240 into 16 at an angle of plus 150 minus 120, so it is plus 30. Okay, so total if you multiply this one, 24 into 16. Okay, so how to do? 24 means 20 plus 4, 16 means 20 minus 4. Okay, so 20 square is 400 minus 4 square is 16. Okay, so 400 minus 16 is 380. So what is this? 384. Okay, so 384 and 0 at an angle of 30 degree. Okay, so 3840 at an angle of 30 degree. So that means this is the complex power. Okay, so there will be active power and reactive power, both will be present. So anyhow here reactive power is 0, this option is wrong. Here active power is 0, this option also wrong. So either this option or this option. Okay, so easily this is a 30, right? So how we need to represent the active power and reactive power? So S equals to, so P plus JQ. Okay, so 3840 cos 30. Cos 30 value is root 3 divided by 2. Okay, plus J. So 3840. So 3840. So sin 30 is 1 by 2. Okay, so 1 by 2. So this value we can get easily. So that is divided by 2 means, so this is so let's see the option you will get. Okay, 1920. Okay, 1920. So J. Then so this value will be 3325. Okay, so 3325 25. Okay, so anyhow, so 1920 into root 3 you have to do. Okay, so otherwise see the option you will be getting from this. Okay, so this option is correct one for this one. Okay, see how we have calculated here, like this we need to do. Okay, otherwise for the calculation of apparent power, another formula also we can use. Okay, like V square divided by Z. So this also we can use. V value we have already, voltage across this one is 240 at an angle of minus 120, and Z value, what is the Z value? Z value is in this phase only they are asking. Okay, B and C phase only, between this B and C phase only they are asking, that is 15 at an angle of 30 degree. Okay, so that we can use here. Similar answer only you will be getting. Okay, for this also. Okay, the next question, a three-phase star connected supply of a phase voltage of 100 volt 50 hertz is supplying a three-phase star connected resistive load of 5 ohms per phase. Find the total active power supplied. Okay, so what they are asking, a three-phase star connected supply. Okay, so supply is star connected and it is so balanced only, they are mentioned already. Okay, so it is balanced 100 volt 50 hertz they have mentioned, that means so it is balanced only. Okay, so no need to mention all are balanced, 100 at an angle of 0, 100 at an angle of minus 120, no need to consider like that. Okay, so this is balanced only. Is supplying a three-phase star connected resistive load. Okay, so star connected resistive load. Okay, star connected resistive load it is. Okay, all the three are 5 ohms only, 5 ohms per phase. Find the total active power. Okay, so 5 ohms, 5 ohms, 5 ohms. Okay, so one is connected here and second one must be connected here and third one is connected here if you take RYB phase sequence. Okay, so this is the complete one and they are asking about complete active power. Okay, so simple, it is a resistive load, so power factor cos phi equals to, so cos phi equals to 1. Okay, so phi equals to 0 for the resistance, angle difference between voltage and current equals to 0, that's why so phi equals to 0, cos phi equals to 1. Active power 3 phase they are asking, so we know, so it is root 3 VL IL cos phi, otherwise so phase also we have to we can consider. So line voltages we have. Okay, so line voltages we have, so that's why root 3 VL IL cos phi we can use like this. Okay, so root 3 value directly we have to give here, root 3 VL, what is the voltage VL? So phase voltage of 100 volts they have mentioned. We can use phase voltage calculation also. If phase voltage is 100, then what will be the line voltage? Line voltage will be 100 into root 3 for this one. Okay, so 100 into root 3. Okay, so IL value, what is IL value? So here voltage from here to here is 100, means 100 divided by 5 is nothing but 20 will be the, so current, and cos phi equals to 1 we have already. Okay, so then you will be getting 100 into root 3 is nothing but 100 into 3, root 3 into root 3 is nothing but 300 you will be getting. Okay, so into 20, so that means 6000. Okay, so this is what you will be getting, 6000 watts. Okay, 6000 watts will be the answer for us. Okay, so no need to do this calculation. Okay, so actually, so power 3 phase we can calculate using the 3 phase active power using the phase calculations. Okay, so 3 into V phase I phase cos phi. Okay, so 3 into what is the phase voltage? They have given the phase voltage. Okay, here I understood it as a line voltage actually, that's why I have did like that. Okay, so here it is 100 into I phase. What is the phase current? See here in this phase voltage is 100, resistance is 5, 100 divided by 5 is nothing but 20. Okay, so like this we can get 6000 watts or 6 kilowatts you will be getting. Okay, so answer for this is option A. Okay, so here we need to understand some points. Okay, so line voltage or line values or phase values, if you do, you will get the same answer only. Okay, so no need to confuse, whichever is comfortable for the given data, so that we have to use. Okay, so like this we have to solve this question. And the next question, read the following statements. First statement, in 3-phase star connection VL equals to root 3 into V phase. In 3-phase star connection VL equals to V phase. In 3-phase star connection line voltages are 120 degree apart. Okay, so what it is? So it is the, so 3-phase star connection line voltages are they are asking about the line voltages. Okay, so we know, so if it is a star connection or delta connection, okay, so star connection or delta connection, so what we need to consider? So voltage, okay, so from A phase to B phase, VA, VB, VC, okay, so star connection or delta connection, anything, okay, are 120 degree apart. Okay, so that means first voltage will be, certain value, okay, so V at an angle of 0 degree, second one is V at an angle of minus 120 degree, third one is V at an angle of plus 120, otherwise minus 240. Okay, so anything is same. Okay, so minus 240 degree. Okay, so these are the three voltages. Okay, it may be phase voltages or line voltages, anything. Okay, so they will be apart. Okay, if you want, you have to draw this. Okay, so vector diagram, if this is A phase and this is B phase and this is C phase. Okay, A, B, C, ABC phase sequence we have here. If you calculate the line voltages, what you will be getting? VA minus VB. Okay, so then you will be getting the line voltage of this one. Okay, so line voltage VAB you will be getting here, and here you will be getting VBC. Okay, so this is VBC, and here you will be getting VCA. Okay, so VCA you will be getting. See here also, how much angle is here? Between these two also same angle will be there. So between these two 120, between these two also 120. Okay, so like this we have to understand. Okay, so this option is in three phase star connection, line voltages are 120 degree apart. Okay, so don't think this is a star connection or this is a balanced or not, like that they have asked. So generally it is balanced only, they need to give. Okay, so the three phase star connection VL equals to root 3 times of V phase. See the magnitude, this is the line, this is the phase voltage and this is the line voltage. So this is root 3 times of, so the phase voltage is root 3 times less than line voltage, otherwise line voltage is root 3 times greater than phase voltage. Okay, so second statement definitely wrong here. Okay, so like this we need to understand. A and C are correct. Okay, so A and C are correct. So which option? Option B is the correct one. Okay, so with this, so the questions for important models from the networks are our circuit subject we have completed. In our next sessions we will see from the other subjects. Okay, all the best. Thank you so much.